everyone, my name's Danielle, and for the last 5 years, I've been working at Apollo to help build tools that help people consume GraphQL APIs. And I've named this talk today GraphQL SQL for the Internet because I want to share an idea with you that inspires my work at Apollo. SQL is one of the most prolific models that we have for storing and working with data in applications today, and I want to show you all how I think that GraphQL can be used to create a SQL-like development experience, but for working with data that's accessed across the web. So with our time today, I want to walk you all through how I think about using GraphQL for general data exploration and analysis, like you would use SQL. It's generally easier to get access to a GraphQL endpoint than it is to get access to a database cluster, and I think that if we can show that GraphQL can be consumed in flexible ways, like SQL, that we can use GraphQL to make a universal access point to data. And GraphQL is already known for its flexibility in that you ask for what you want and you get back what you need. So I'm not talking about flexibility in terms of what you select in your query. I'm talking about flexibility in terms of what you use GraphQL to do, beyond using it as part of the mechanics in building an app. So with our time today, I want to talk about 3 particular characteristics of SQL that I think are important and analyze whether or not GraphQL has them too. Number 1, the language is expressive. I'm someone who consumes APIs and data tables more than I create them, and for me, I need to be able to plug into a dataset and ask arbitrary questions, not just consume what I've been given. Number 2, queries are performant. These days, every database is optimized for something different, and because GraphQL is deployed as an additional layer in the stack, it's often critiqued as having this n+1 problem that adds a layer to our processing. So is it even possible to use GraphQL in an open-ended way, like for data analysis, because it was actually designed to be used for application building, which has very different needs. And then number 3, the ecosystem around SQL is very mature. For any piece of technology that you implement, you always need tools to understand what's going on, and for SQL, which has been around for such a long time, the ecosystem is so mature that there are even many different variants and implementations of SQL that have all been optimized for different things, as well as there being diagramming tools, tracing tools, tools to federate different deployments together, etc., etc. So what does that actually look like for GraphQL, which is a much younger technology? So let's dive into number 1. I want to start by walking you through a SQL query and comparing the expressiveness in SQL to GraphQL. So this is a SQL query that I have here, and I've written this query many times over, and I consider this to be an analytics question. For each account, how many users have I seen in the last 30 days? And if I break this query apart and look at the different elements of it, there are some distinct things that stand out. The select here lets me control what I'm asking for given a platter of options, where the options are columns in my table, and I get to choose only the data that I need from this. In GraphQL, we have the same principle, that you select only the fields that you care about from your API, and that alone is what a lot of people get excited about by using GraphQL in the API world. The where here is a conditional selection. I only want to select users if I've seen them in the last 30 days. With GraphQL, we have nothing built into the language itself to express a filter like this, but there's nothing that stops you from building it into your GraphQL schema either. You can use GraphQL arguments and GraphQL directives to achieve filters the same way you can use the where clause in SQL. The join here lets us select data across multiple tables, and in SQL, you only ever join 2 tables together at a time, usually. So as a query writer trying to get a broad view of your data, you often have to write a lot of joins together across quite a lot of tables, and you need to know your data well enough to know how to do all of that. And with GraphQL, you actually build your join logic into your schema. So any person consuming your API doesn't have to know anything about how your data is joined to actually successfully consume your schema. So I think that the GraphQL experience here is much better for the average data browser than the SQL experience in this case, because the joins are built in and you don't have to redo them every time you write a query. And then the last thing I want to point out for now is this ability to group and count. The idea that we can apply aggregation and array functions to our queries to do computation is something that's built into SQL, and it doesn't really exist in GraphQL. If you want to query something that's computed, you actually have to build those computed fields into your schema, which means that you need to anticipate them. And that works for application use cases where your API needs are often very well defined and not changing too frequently, but it's not as good for the open-ended use case like the SQL analyst use case where your questions change all the time. And personally, I think it's a very crucial thing in the SQL world to be able to do this computation that is just missing with GraphQL. But lucky for us in GraphQL, there's a concept called a directive, and that basically functions as a way for you to create your own extensions to the language, which you can do to add things like computation functions. So in the spirit of what we're talking about here with query flexibility, I wanted to share a project with you all from the early days of GraphQL called GraphQL Lodash. Lodash is a utility library in JavaScript that implements a large number of functions to transform arrays and objects. These functions include filter, count, min-max, sort, reverse, etc. And GraphQL Lodash is a package that you can add to any node server, and what it does is it provides support for applying Lodash functions to your queries via directives, and so you can actually transform the shape of your query results that way. So here I have a little demo for you, and this is the Apollo sandbox pointed at an API that returns information about countries. And one of the Easter eggs of the sandbox is that it actually has these GraphQL Lodash functions built in. So here, if we look at our query, we can see that this is asking for countries, it's asking for the continent of each country, and we can run this query normally. But let's say we were approaching this API, and what we were actually interested in knowing is how many countries exist on each continent. There's no way to really do that in our tools these days without downloading this data and putting it somewhere else to parse that information out. But with something like GraphQL Lodash, you could apply a Lodash directive here, and we could use the count by directive, and let's say we want to count by continent.name. Now when we run this, our result tells us exactly what we wanted to know because it's aggregating by continent name. So a few things to point out about this example. The ability to aggregate, group, and count, and generally apply transforms to query results is a really powerful thing in my opinion. This is what lets you ask questions to your data and get answers without actually having to leave the context of your tool, which is crucial. This is also what enables people to use GraphQL schemas beyond what they were originally imagined for. But on the flip side, GraphQL Lodash is not particularly intuitive necessarily. It's taken me several hours to figure out how to even fiddle with it. And the bigger, even more important thing to point out here is that transforming data like this is actually breaking a principle of GraphQL, which says that your responses need to stay congruent to your queries. So for use cases like this, where you're writing queries to data to use within a console, I think that principle and breaking that principle is not a huge deal because it's all scoped to what you're doing in the moment. But if we were to actually try to take this query and put it into our code, that's where things would get iffy because oftentimes in our development environments, we're using other tools like code generation, and those tools all rely on us staying spec compliant. So I wanted to share this with you as an example of where I think the GraphQL language is lacking in expressiveness. But GraphQL also has this great backdoor of directives that enable us to basically customize anything we could possibly want. So we're not in a completely dark corner. So let's move on to characteristic number 2. Queries are performant. This is maybe a little bold for me to say about SQL because there are a lot of SQL deployments that are not performant, and that is its own specialization alone. But what I wanted to talk about, and the point is that data these days is usually stored in databases that specialize for the way you're going to want to get that data out of the database. So databases are highly specialized these days. And my question is, with GraphQL, is there some way to preserve that element of specialization that you're getting from the database, even though we are proposing kind of entering the data point of access at a higher level in the stack? So you may have your data stored in lots of different ways, lots of different places. This is pretty common in organizations these days. And you may be trying to provide one single graph that combines all of these things together. So the question is, how do we do that in a way that could still be flexible and still be performant? And the implementations that I've seen that have been the most interesting in this category have been the ones where people try to map their GraphQL schema to the database queries that they are making themselves. Because if we can basically just translate these two languages here, then the actual processing of the data inside these queries can piggyback based off of the database layer itself, and GraphQL can stay as thin as possible. And there are actually a lot of tools out there that help you do query translation between GraphQL and SQL especially. There are even companies that provide software for GraphQL on top of SQL as a service. And in all of those tools, what you're ideally going for is an ability to translate any GraphQL query that comes in into the precise SQL query that should fetch that data. And what I have on the slide here is just an example of how to do that in one of the libraries out there that's called JoinMonster, but there's a ton of online material for doing this, especially with SQL and GraphQL. And something that's a little bit closer to our hearts at Apollo is how do I translate Druid queries to GraphQL. So Druid is a time series database, and it's been designed to help you query analytics data over large swaths of time extremely performantly. And we actually built a Druid to GraphQL translator at Apollo a couple of years ago. And our goal at the time was to provide a flexible API for querying some stats that we have out of our Druid database. So we were basically generating a portion of our GraphQL schema from Druid, and then you would run these GraphQL queries and they would be transformed into Druid queries. And so I wanted to show you all a little bit about what that looks like. So here we have a query for a service, and this is an example service where a service represents kind of a graph in our model. And there's a portion of the schema that is actually directly translating queries to Druid. So if I look at all of the fields under this type in the schema, all of these different columns, these are actually different data tables inside Druid. And if I want to query out of the field stats table and I want to get some metrics and I want to ask for request count, and let's say I want to look at the request count over the last 5 minutes, which is the last 300 seconds, I can do all this, and this is basically just translating this GraphQL query directly into a Druid query. And one of the most interesting parts about this schema is that there's a section of this schema called group by, and we can ask for group by client name, for example. And if I run this, now I'm grouping by client name, and because I'm grouping by client name, this list has gotten a little bit longer. Client name is actually a column in my database in Druid, and so this is now performing aggregation. And if I ask for another field to group by, like query name, now we're doing more aggregation, and you'll see we have even more results because there are more combinations of client name and query name. So let's talk a little bit about how this worked. I would say this worked out extremely well on the flexibility side of things because you could just make Druid queries, which is not something I would have otherwise been able to do because I don't have direct access to the Druid database in that way. And the flexible queries here really did let us iterate quickly with the feature work because we didn't have to know what our precise end goals were through the feature work in order to get started. And this generated schema has also been nice because it keeps itself up to date. So every time we add new columns to our tables, our schema will pick up those columns with no additional work from us. On the flip side, I would say the jury is still out as to whether this Druid schema that we made actually covered our product needs. It was a big pain point that the return data wasn't in a shape that was formatted for our clients because we actually ended up needing to still do a lot of front-end computation to get the data into the right shape for our components. And the data also tended to come over the wire in a pretty large, unoptimized format. And then I would say the other bigger anti-pattern with this is that it was a confusing model to have the group by field be a selection in this schema rather than something like an argument. This was actually unintuitive to a lot of our teammates and it caused a lot of confusion. So there are a lot of pros and cons to an approach like this, but the main point is that it's possible to translate GraphQL directly into other, even very complex database query languages. And I think that that makes these data sources underlying way more accessible if we can translate them into GraphQL, because otherwise people don't generally have even access to those types of things. So our last characteristic of SQL to cover today is that the ecosystem is mature. And there's a famous saying out there that good designers copy, but great designers steal. And one of the things that's been interesting to watch for me personally over the last 5 years is how many of the tools from the SQL ecosystem have actually been brought to GraphQL as well. There's a huge breadth of tools out there now, from SQL relationship diagramming tools that people have built to visualize GraphQL schemas. This one is one that's from the early GraphQL days called GraphQL Voyager. There are even development environments out there that have been specifically created for people working with GraphQL. So here we're showing the Apollo Sandbox, which has an inline extract variables utility, as well as a table mode for viewing results. And those are functions that are very special towards working with GraphQL itself. People can even combine graphs together using GraphQL Federation, and there are a lot of tools out there to support you in doing that. This is a query in a federated graph, so this is a graph composed of graphs, and this is a diagram of the query plan for how that query is going to get fetched. So this diagram is saying that one query that we've requested on the left side is going to go through and fetch all of its different components from all of those different subgraphs. So I could probably give a whole talk about each of these tools individually, but I just wanted to share with you all that there's a hearty ecosystem out there, and there's enough mature GraphQL usage now that we actually know what kinds of things people need next, and a lot of those things are being developed. So let's come back to our original question. Can we use GraphQL to make a universal access point to data? For the last several years, I've personally been using GraphQL way more often to do things like look up information about an account, or debug a problem, or run some analytics, or check what the status of something being built is. I've been doing that way more frequently than I've actually been using queries inside of code. And I think that there's a very big opportunity for more people to take advantage of GraphQL in that way, outside of the standard GraphQL using it for development context. And I think that if we can make our tools accessible in a way where people can use GraphQL even if they're not typically doing development, a lot of people will actually be able to do their jobs a lot more effectively. And I do think that the tools and the technology out there allow us to build GraphQL APIs in such a way that they can be used in this way. The vision is really big. The work is hard, but I think the payoff is there, because if we can make graphs really accessible to use and we can start combining them together, then the limits here are almost endless. So thank you all for coming and listening today, and if you're interested in trying out this query tool that I was showing, that is the Apollo Sandbox, which you can find at sandbox.apollo.dev. And if you have any questions, please don't hesitate to ping me on Twitter. My DMs are open, and I always look forward to meeting new folks, so I will see you on the internet.